friction problem, what I call the wagon problem. I think it's a lawnmower in your book. It's on page 114, number 48, and it's one of your homework problems. But I'm going to change it up just a little bit. I have a 10-kilogram wagon here, a little red wagon with some black wheels. It's being pulled at 100 newtons, but it's not being pulled straight across. It's actually, the handle's going up at a 30-degree angle, and the surface is pretty slick at a coefficient of friction of 0.2, so not too much friction acting against you there. And what they want to know is what's going to be the acceleration of the wagon. So let's talk about where I begin all these formulas. Once again, I always start off with the sum of all the forces. And the forces that you have here in the x direction that actually make you go forward are the pull force, and you also have friction. So what I'm going to do is I'm going to have to fill all these in, and I don't know the sum of all the forces, so I always substitute in a formula, and what we substitute in is the sum of all the masses times the acceleration. And so that's going to be the mass of the wagon times the acceleration of the wagon, which is what we're looking for. The pull force, well, you can't put in 100 newtons because the pull force is in the x direction. So you got to figure out this little guy right here. Well, since that's the adjacent side, I'm going to take the cosine of 30 times the hypotenuse, which is 100. And that's going to give me the pull force there. Now you got to figure out friction. Well, I'm going to come over here and do some stuff with friction. Okay, I'm going to put my friction in green. And let me show you what we're going to do here. Okay, so I'm going to switch my formula for friction around. If you remember, the formula I gave you was friction is for fun, right? And so I'm going to bring down my normal, not my normal force, but my coefficient of friction, which we said was 0.2. So I'm going to put my 0.2 in there. Okay. But I got to multiply that by the normal force. Now, the normal force on a flat surface is its weight. So I'm going to take m times g. But, here's the great big but. That handle pulls up a certain amount. So therefore, all of the weight of the wagon doesn't stay on the ground because you're actually got to pull the wagon partially up. So I got to add to that the sine of the angle, which is 30 degrees, times the hypotenuse of 100. Now, the reason why I got that, once again, the weight goes down. Here's the weight pulls them down like this. Okay, so this is mg right here. But this part of the handle pulls up. That's what I call, oh, I just screwed that up. So this is going to be an up force due to the handle. So I have to subtract this force up from that weight going down. Now, if you notice, I added it here, so just watch how that happens, because this gravity is going to be negative. So what I'm going to do is I'm going to say my friction force, keep that 0.2 there, is the mass, which is 10, times a negative 9.8, so that's the weight going down, plus the sine of 30, I think is 1/2, I think, times 100. So let's get an answer for that. And when you get the whole answer for the parentheses and multiply it by 0.2, I now have a friction force of negative 9.6. Now what I have to do is I got to take this answer and plug it in up here, okay? So I'm going to add to this cosine of 30 times 100, I'm going to add that negative 9 point, actually it's 6, not 9.8, but 9.6. I made a mistake down there. That should be 9.6, okay? And so when now, let's plug in some more numbers. The mass of the wagon was 10 kilograms times my acceleration equals the cosine of 30 times 100 minus the 9.6 gives you 77. Okay? I'm then going to divide both sides by 10 kilograms here. And so my acceleration of this wagon would end up being 7.7 meters per second squared. So not a too awful bad problem, but you got to remember to subtract that force up minus the normal force when you're calculating friction. Hope you have a great day and good luck on these problems. Take a few of them at a time. Bye. Love you.